Okay, so we have seen already the derivative function, right? But so far, we haven't really tackled the question of how to compute the derivative. So you give me a function with a formula, how to compute the precise derivative function. So now it's the time we start doing that. So from the previous video, we have a few guesses. Okay, so for example, we had a guess. We saw that vertical shifts in the graph of a function don't affect the derivative, right? So that means that when we have a constant, whatever constant we have, the derivative has to be 0. Okay, so the function that is constant, the slope is 0. Okay, geometrically this is clear. Let's see if we can do this by the definition. Let me use the limit as h tends to 0 of f of x plus h minus f of x divided by h. Remember, there are two definitions for derivative. Okay, one, the limit is as x tends to 8, the other one is as h tends to 0. They work the same. Sometimes one or the other may be more convenient. We need to be able to work with both. Okay, in this case, actually this is very easy. So when you see you need to compute the derivative using the definition, just don't freak out and write down the definition, and everything will take you to the next, and you'll be done before you know. Okay. All right. So f of x plus h, because the function is constant, c, and f of x is also c, divided by 8, but we have 0 divided by 8, so that is 0. Okay. So very easy. Another thing that we have been using a lot, for example, the derivative of x. Okay. We have seen that this is equal to 1. Why? Because the slope of x, because it's a linear function, it's the coefficient. And the coefficient in this case is 1. Okay, but if we do the definition, this is very simple. Limit as h tends to 0, x plus h minus x divided by h. So h over h is 1. So this is equal to 1. Okay, so we have already two formulas that we need to remember. The derivative of a constant is 0. The derivative of x is 1. And we have this guess about a polynomial, right? So we had a polynomial of degree 4, and based on the graph of the derivative, we were guessing that the derivative was a polynomial of degree 3, so 1 degree less. That is actually true. So x to the n, the derivative is n times x to the n minus 1. Therefore here it goes multiplied by n. Okay, so somehow you take the degree, bring it down in front of the x, and then discount 1 unit from the numerator. This is true for any number n. Okay. This is easy to see. If we have n equal to, for example, sorry about that. So the limit, this is going to be the limit as h tends to 0, the definition of x plus h squared minus x squared divided by h. Okay, so we need to expand that square. This is x squared plus 2xh plus h squared minus x squared divided by h. The x squares go. All right, and then we can simplify the h, right? and take the limit. So we get 2x. And this is in agreement with the formula because you see n was equal to 2, so goes in front. And then we have n minus 1, which is 2 minus 1 makes 1 for the exponent, okay? Let's try also n equals 3. Let's write down the definition. Let me change in this case. Let's do the other one. It's going to make our life easier. Let's say x to a divided by x minus a. Okay, I know it's going to be easier because I already tried. If you don't know, just try one of the two. If it gets very complicated, try the other one. If both are very difficult, choose the one that you like best, okay? It's always, one of the two is always easier. So this is the limit as x tends to a of x to the power 3 minus a to the power 3 divided by x minus a. And we can factor here x minus a in the numerator multiplied by x squared plus ax plus a squared divided by x minus a. There's the cancellation. And then this limit is a squared plus a squared plus a squared. That makes 3a squared. Okay, so the formula again works. Okay, because we have the n, that is 3 multiplying, n minus 1, which is 2, is the exponent. Okay. Now, something very important. Here I said for any number. When I say for any number, I mean it. I don't mean an integer number or a whole number. I mean it can be positive, negative. Okay. So it doesn't matter. Let me write it down. Doesn't matter that n is positive, negative, a fraction, okay, a rational number, or even irrational. No matter how complicated the number is, that's okay. All right, let's do some more examples. So now we don't have to do once we know these formulas, we can just apply them. We don't have to do the definition every time, except if the problem is asking do by the definition. In that case, you have to do by the definition. If you don't, you are not answering the question. Okay, so let's say ddx of 5. I'm going to write the examples. I give you a moment to think what are the answers. So ddx, x to the power 4. Then ddx 1 over x, ddx square root of x, and then let's do one more, ddx x to the 3 halves. Okay. You can pause the video for a moment if you need more time. So ddx of 5, it's a constant, so this is 0, right? X to the power 4, so it's going to be 4 times x to the power 3. Now, ddx of 1 over x, we need to remember that 1 over x is x to the minus 1. So this is minus 1 times x to the negative 1 minus 1. So this is minus x to the negative 2, or negative 1 over x squared. Okay. More things, the square root, we write it as x to the 1/2. So this is the exponent 1/2 times x to the 1/2 minus 1, which is minus 1/2, divided by 2. Or if you want, we can write as 1 divided by 2 square root of x. Okay. And then if we have 3 halves, well, no problem, that's the same thing. Bring the exponent down x to the 3/2 minus 1. Okay, and this is 3/2 times 3/2 minus 1 is 1/2. So this is 3/2 of the square root of x. Okay. So there are a few things. These are the basic formulas, right? But then there is a very nice property that derivatives have, that is that differentiation respects constant coefficients and addition. And addition, okay? What do I mean by that? So what I mean is, and we will see this a lot in the problems, is if I have d dx of 5x squared minus 7 square root of x plus 2, I can split the long formula into smaller pieces. So this is d dx. So it respects the addition. That means that I can break the formula, okay, wherever I have an addition or subtraction. So in this case, I have the derivative of 5x squared plus the derivative of negative 7 square root of x plus the derivative of 2. The derivative of 2 is 0. So that one, we are done. And now respects constants. That means that these constants here, we can pull them out. So this is 5 times d dx x squared minus 7 d dx square root of x. And these we already computed, okay, but they are simpler. So the trick here is to break the formula into smaller pieces until we find something we know the formula for, okay? So this is 5 times 2x minus 7, and then this is 1 divided by 2 square root of x, okay, because we just computed it. So this is 10x minus 7 divided by 2 square root of x. And this is the final result. Okay, I'm going to leave some practice problems for you to do. Okay, so for example, f of x equals 3x squared plus 19x plus, minus 6. You can do that one. Or we could take 8 square root of x plus 2 divided by square root of x. Or for example, you can do 2x to the 1/3 minus 2x to the 20 plus 3. So you can try these examples on your own.